Hi, we are going to talk about a clock reaction. These are kind of cool reactions. So in a clock reaction, you are going to mix two substances, time it as soon as you mix those two substances, and then something will happen. A color change will occur, and you stop the timer right when the color change occurs. Couple of important things to remember. Put in the indicator. I can't tell you how many times I've had students take flask 1, flask 2. They put everything in flask 1, everything in flask 2. They go ahead and mix it, and they stir and they stir and they stir and stir, and it never changes color because they forgot to add the indicator. In my lab, we use a starch indicator. It's just starch, and it turns from a clear, kind of like a creamy, to a purple color. So make sure you have that indicator in there. It's easy to forget it. Next, determining the relative rate of the reaction. So you mix this, you stir, 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 boom, it changes color. The way to get the relative rate of reaction, because you're creating a data table that you'll use to calculate the final rate equation, the rate law, to get that relative rate of reaction, you record the time. So let's say that this turned purple in 45 seconds. It's 1,000 divided by the time it took for it to change. So if we took our 1,000 divided by the 45 seconds, the time it took for this to change, then the relative rate would be 22, and the unit on that is going to be molarity per second, because I timed it in seconds, and I recommend that you time in seconds. You might have longer reactions that you're doing that could be minutes. I would still do it in seconds. As long as it's like 10 minutes or less, I would put it in seconds. And I will be honest with you, why you do the 1,000 divided by the time, I'm not sure. I'm not totally sure, but I know that that's our practice, how we do it in the lab. So I'm sorry that I don't have a good answer for you on that. Now, in order to create this data table so that you can compare concentrations, ultimately we're trying to get the orders, the M and the N. You have to have the right concentrations. So here's how you're going to calculate it. Now, this is going to be my flask 1. Actually, let's go like this. This would be my flask 1, and this will be my flask 2. I'm going to put 10 mils of 4 molar acetone with 10 mils of 1 molar HCl. And then in this one, I'm going to put 10 mils of a 0.005 molar iodine and 20 mils of distilled water. So I take these, I mix it, I start timing right there. It changes color, boom, stop the timer. Oh, hey, that was 45 seconds. Well, to take these numbers and put them into our table, you have to have the final concentration. It's the final concentration when you mix all of these together. So I want to show you how to calculate the final concentration for the acetone as an example. So final concentration, we just use our dilution formula, M1V1 equals M2V2. So this is my initial volume. So this would be my V1. That's my initial molarity, that's my M1, and I want to know the final molarity. M2 is my unknown. So I'm going to divide both sides by V2, and we will get M2 equals M1, V1 divided by V2. Well, I see my V1 and my M1 was my V2. Well, it's adding all of these together. It was everything that I had in both of these, and when I mixed them, that's the final concentration. So you have to add up all of these volumes. It's going to be 10 plus 10 plus 10 plus 20. 50 mils is the final volume. So I'm going to put a note over here. My V2 is 50 mils. So let's go ahead and plug everything in. The molarity originally was a 4 molar. The initial volume right there was 10 mils. We're going to divide that by 50 mils. And so this is going to be, what is it, 0.8? Let me double check. I put it, oh, I think I put that away, so sorry. So that's going to be 1/5. Yeah, it's going to be 0.8, and the concentration will be molar, 0.8 molar. And then you do that for everything else. That would be our first trial, okay? So I'd find the new molarity for acetone, hydrochloric acid, and the iodine. Then when you run this again, you've probably already been given instructions, but when you run it again, you change just one of these. So maybe I would double the amount of acetone, which means it would double my concentration. Now, to take this data and calculate the rate law. I will put at the bottom of this the link for how to determine the rate law mathematically, just to help you with your math in case you need a review on how to determine the M and the N, that rate law mathematically. Okay, so your big takeaways. Remember the indicator. Okay, that's just from experience. Every year I'll have groups of kids forget indicators and they have to start over. When you're doing the relative rate, it's 1,000 divided by the time. Find the new molarity. So it's after you add everything, you have to find that molarity using the dilution formula. And then you're just going to take all the data that you collected, those new molarities, and determine the rate law. Okay, nice work. It actually goes really, really fast. It's going to take you longer to do the math than to actually do the lab. So have fun. Thank you.